Hello and good evening, and welcome back once again. The last stretch of our classes for this preliminary exam, and of course, preliminary and the main. So, I have understood that we have to some of the classes in science tech, some classes in environment. These are the two main things that are left. After this, if something else is there, that is something for the main exam. If at all something is there, we will see that we have a special main point of view session also after the preliminary exams called 600 plus. So, that is a separate package. So, we will talk about that later. So, we may be dealing something like that. So, right now some of the issues related to science and technology, and especially space technology, nuclear technology, biotechnology, and these are the areas where questions are generally asked. Okay. So, I will be talking about that, and whatever else possible, whatever is required, I will be definitely doing that. Okay. So, that is the situation. One second. So, the space technology. So, this is Sat Sri Akal sir, and good evening. I am so good to see you. Very good. I am fine. Advance happy Onam. I mean Rohan and all. I think even I think you will be you are not going to attend subsequently. I don't know. I mean, hope you will be attending further classes also. So, happy Onam to all of you that is there, and I am doing well. Happy to see you after a gap. Yes. So, because of the classes which were going on, or with the current affairs and all which were going on, that is why I was not coming. So, anyway, so here and I will be talking exclusively, or rather I will be starting with space technology. Okay. And in science and tech, we are also I mean, I will be especially covering nuclear tech. Then a third thing I would like to cover, that is something related to biotech, IT, etc. So, so that many of the questions which are being asked, whether it is in preliminary, whether in the main exam, both can be covered. So, this is for both preliminary as well as for the mains. Okay, both. Both preliminary as well as main. So, feeling happy to see you after a long time. Yes, I am also feeling happy to come to this batch, because we were doing in other classes. So, really happy. So, coming to the space technology. So, many things in the current affairs discussion we have done, but here I will be doing a bit systematically. It is not based on some news which has happened recently. Okay. So, there is a difference. So, please understand the kind of questions which are ultimately being asked is slightly different from the main exam. Preliminary point of view, we have seen many things, but even in preliminary there are questions beyond what is current affairs in science and technology. That is what we are going to cover right now. Okay. So, in space technology, first of all, let me talk about the need for space research. See, space research is something very interesting, and right from time immemorial, our forefathers had an interest in beyond our earth, the stars, the moon, the sun, the planets, all they had interest. But by 1950s, we have realized that yes, we have not only have a general interest in knowing where we are and what we are. We started understanding that there are great potential for us in space research for our socio-economic development of the country and the world, for the socio-economic development of the world. Okay, for the socio-economic development of the world. And see, and initially there is no clarity, but today we have, and we cannot survive without space technology in our day to day life. For example, our communication, especially the TV, radio communication, it is with the help of the satellites. Then even long distance telephone, in remote places. See, cable, it is definitely there, optical fiber definitely there, but even today satellites play a very crucial role. Now, according to some experts, especially the Tesla company and all, they are talking about internet connectivity through satellites, or satellite, thousands of satellites will be launched into the space, and these satellites will provide broadband connectivity for broadband connectivity throughout the world. Near Earth orbit satellites, thousands of them will be launched, and SpaceX, the company, they are launching thousands of satellites. They have already started the process, thousands of satellites into orbit, and these satellites will provide you seamless communication, broadband connectivity, high speed internet connectivity through satellite. Right now we are not enjoying it. They are starting in US, and slowly they will be spreading across the globe. Just imagine, that will be something revolutionary with the help of the satellite technology and satellites. So, in communication. Number 3, in weather forecasting. In weather forecasting. Number 4, in resource management. In resource management, meaning how to utilize the resources on the surface of the earth and even below the earth, in the in the interiors, the mines, or in the below the oceans, on the ocean surface or the ocean bed. So, we are talking about resource management to remote sensing satellites. We will be talking about that elaborately. Resource management, the forest cover, the crop acreage, the crop productivity, and name anything, it will be coming into picture through this. Number 5, we are also using this satellite technology these days for navigation. GPS, global positioning system, the American program, like Indian program is there, the Chinese program is there, the European program, the Russian program. So, if you have to travel today, we would like to have the help of the satellite navigation. Of course, the Google through the in our mobile phone, what we are using is not through satellite, but more accurate communication, more accurate satellite navigation can be done through satellite, and all military, military hardware, or all military vehicles, aircraft, ships, even tanks, all of them are fitted with GPS. So, that global positioning system is satellite based navigation system. So, what we use as the navigation using Google, using internet, that is a different thing altogether, but what we are talking about is satellite based navigation across the globe. Even India has a program, I will talk about that. So, for navigation, for any movement we need satellite, for any resource management we need satellite, For any weather forecasting, we need satellite. For any TV, radio communication, we need satellite. For broadband, connectivity in future, maybe in the next couple of years, through through satellite. So, there is a huge potential. The socio-economic development of the country, the satellite program or the space program in India plays a very crucial role in the socio-economic development of the country. If you have to elucidate, you have to talk about all these 5 things. And then of course, in our astronomy also, we are using satellites in astronomy to know more about the other planets, other galaxies, even to know within our galaxy the other stars and the surrounding planets and all. We are also very keen for exploration of Mars, Moon, maybe Jupiter, all the surrounding the planets, and we are even thinking even asteroids. Ultimately, even some mining, so bringing some very costly resource back to Earth. All these possibilities we are talking, even colonizing Mars in future. So, huge plans already, and that is how. So, the question can be how the space technology can help in the socio-economic development of the world and the country in particular. So, that is what we are, that is why space technology is so important. In science and technology, maximum development for India is in space tech development. So, how space research can help in the socio-economic development of the country. So, this can be one question for the main exam. This is what precisely we are going to elaborate in the coming discussions. A lot of discussion need to be done, but broad headlines I said, heading I said. Now, it has to be used to elaborate your answer. So, 6 points I said, and we will be elaborating it in the coming class. Now, coming to the history. So, this is one question, maybe 250 words, maybe 150 words in both. You please try. Now, coming to the history. Please do not forget, the first artificial satellite in 1957 by Soviet Union was Sputnik 1. Sputnik 1, it was in 1957. And then immediately after that, I think in 1958, Explorer 1 by USA. 1958, Explorer 1 by USA. Then in 1961, the first man in space, that was the Russian Yuri Gagarin. The first man in space who revolved around the earth for a couple of hours and came back, first human in orbit, and it was in a orbit module called Vostok 1. Using Vostok 1, he has traveled or has revolved around the earth for a couple of rounds, couple of hours, and was brought back to earth, landed back safely. Then in even US also subsequently sent their astronaut in space in the same year, but Yuri Gagarin from Soviet Union was the first to go. Then in 1969, as we know, Neil Armstrong in Moon and Apollo. Okay. Neil Armstrong in 1969, first human being on Moon, Apollo 11 mission. So, that is how the globally the things started evolving, and then even they started talking about a space station. The first space station again by Soviet Union in 1971, the first space station 1971 called Salyut 1. Salyut 1 in 1971, 1973 Skylab by USA. Okay. And that is how the whole thing. So, the Salyut 1 was there for 23 days, the Skylab mission was for a couple of months. Okay, I think 6 months Skylab was there at that time in 73. So, that is how globally developments took place. Then if you look at India, so this is the global scenario. If you look at India, our space research and development started in 1950s, but a concrete picture came up in 1962. Jawaharlal Nehru is the architect of that, absolutely no doubt. He had a vision, that is why he was talking about that. In 1962, the Indian National Committee for Space Research was established under Department of Atomic Energy. Indian National Committee for Space Research is known as INCOSPAR. Okay. Indian National Committee for Space Research in 1962 under Department of Atomic Energy. That was in 1962. Okay. And Vikram Sarabhai was the person behind it, no doubt regarding this. And in 1969, this INCOSPAR was converted into ISRO, Indian Space Research Organization, in 1969 within DAE, Department of Atomic Energy, and in 1972 Department of Space was created. (1972) Department of Space was created. Okay. And ISRO was brought under Department of Space subsequently in 1972, and ISRO came under this. That is how the developments have taken place. So, a long journey for India, and ISRO has grown in the most successful scientific organization in India. And India is one of the best when it comes to space research in the world itself. We can easily be the top 5 or 6 countries in the world right now when it comes to space research. We have done exceedingly well considering our limitations in technology, limitations in money to be spent, the budget. We have done a wonderful job when it comes to our success in space technology and the satellite launch, the rocket launch, everything. Now, whenever we talk about a space technology, so there is a limited history about the whole thing. Now, coming to space research, space research should be divided into 2 broad programs. One is the launch vehicle or the rocket program, and the second one is the satellite program. Okay, once it is launched, the satellite. Okay. And in the launch vehicle, we have 3 or 4 varieties we can easily talk, which are being ultimately used. So, we have something called SLV 3, satellite launch vehicle, then ASLV, augmented satellite launch vehicle, PSLV, ASLV is augmented polar satellite launch vehicle, GSLV, geostationary satellite. So, different launch vehicles. Okay. So, one is about the launch vehicle SLV3, ASLV, PSLV, GSLV, etc. When it comes to satellites, there are a series of them. One is the resource management satellites, another is communication satellites, a third is navigation satellites, astronomical satellites for studying and learning about astronomy. So, it is a satellite program. Then a third thing we can talk about is a mission to space. Okay. A third thing so, launch vehicle is number 1, satellite is number 2, space missions. So, manned mission, number 1, number 2 mission to Mars, Moon and other planets. Okay. So, there can be a broadly these kind of divisions we can say. So, space research one aspect, launch vehicles, the rocket making. Second aspect, the satellite making. The third aspect is space missions, like the manned mission, the mission to Mars, Jupiter, Moon, etc., etc. So, and within that there are multiple subdivisions. So, when we talk about space research, okay, so these are the things coming to my mind where we will be discussing various aspects of it. You might have also heard about it. So, that is how we will be broadly classifying the space research. The launch vehicle program, the satellite program, the various missions to in various celestial bodies, including the manned mission in space, the permanent the Skylab type International Space Station and things like that. So, all these things we will be discussing in this particular in 3 broad headings. Now, the next point I would like to discuss here is, so there is one aspect. The next point is the ISRO and the various organizations under it. ISRO and various organizations under it. First of all, Indian Space Research Organization, the headquarters is in Bangalore, and it provides the overall guidance, direction and what needs to be done. So, headquarters is in Bangalore. When it comes to the main research centers, number 1 is VSSC, Vikram Sarabhai Space Center. Vikram Sarabhai Space Center, VSSC. This is located in Thiruvananthapuram. Kerala. That is the largest center of ISRO. Vikram Sarabhai Space Center, Thiruvananthapuram in Kerala is the largest research center under ISRO. And the focus in Vikram Sarabhai Space Center is rocket development. The engines, the various stages, stage 1, stage 2, stage 3, the engine, the fuel, its integration. Ultimately, all missions, each and every mission of our ISRO, ultimately it is done through the VSSC center, because that is how you can travel. The rocket is the vehicle, okay, and its engine, the fuel, etc. The rocket is the vehicle. Its research, that is VSSC. That is the most important. Number 2 is the ISRO Satellite Center, or ISAC. Okay, ISRO Satellite Center. One second. It is also now it has been renamed after one of our pioneers. Now, Vikram Sarabhai, he is the pioneer, Nehruvian time, Vikram Sarabhai, and please do not forget APJ Abdul Kalam. Both of them played a very crucial role in the satellite, the space program. Subsequently, APJ Abdul Kalam was shifted to the missile, he became the missile man. He has subsequently shifted to the missile development, but missiles as well as rockets, the technology is same. So, Vikram Sarabhai, APJ Abdul Kalam, then a series of scientists at that time, another famous scientist who was the chairman of ISRO and all for many years, U.R. Rao. So, this ISRO Satellite Center is named after U.R. Rao Satellite Center. ISAC has been renamed in 2018 as U.R. Rao Satellite Center. This ISAC, ISRO Satellite Center was the earlier name, now it is known as U.R. Rao Satellite Center. U.R. Rao, again another pioneer. So, we have Vikram Sarabhai, we have APJ Abdul Kalam, we have U.R. Rao, another great scientist Satish Dhawan. We will be coming to after him also there is a space center. So, I will be talking about that. Then Madhavan Nair. These were some of the real pioneers in this field. We will come to that. So, a second scientist after whom ISRO Satellite Center, and ISRO Satellite Center's main activity is design and development of the satellites which we are launching. Design and development of satellites. So, Vikram Sarabhai Space Center, design and development of the launch vehicle, ISRO Satellite Center or U.R. Rao Satellite Center right now after 2018, it is for design and development of the satellites. Then coming number 3, a third very important center, is the Satish Dhawan Space Center at Sriharikota. This is our spaceport, and it was earlier it was known as SHAR, Sriharikota High Altitude Range. SHAR, Sriharikota High Altitude Range was the earlier name. Now it has been renamed, or rather many years before, that is Satish Dhawan Space Center. This is the spaceport of India. This is the spaceport of India, like seaport, airport, okay, railway station, bus adda, spaceport, okay, spaceport from where the rockets are launched. And in the spaceport you have launch pad, like platform number 1, platform number 2, we have LP1, LP2, launch pad number 1, launch pad number 2, like that we have 2 launch pads in Satish Dhawan Space Center. This is located at Sriharikota. Sriharikota is an island in Pulicat Lake in Andhra Pradesh, Tamil Nadu, Andhra border. So it is located in Pulicat Lake. Sriharikota is a island in the mouth of the Pulicat Lake, 100 kilometers north of Chennai. But in Andhra Pradesh, okay. So that is the main launch station for India. We have other launch stations also, but this is the main station. Okay. There is a launch pad for in upper atmospheric studies. There is another one, but that is a small one right now. It is a research station for us, that is called Tumba and TERLS, Tumba Equatorial Rocket Launch Station. That is why TERLS, Tumba Equatorial Rocket Launch Station. This is located in Thiruvananthapuram, just north of Thiruvananthapuram. In fact, ISRO started here. This was the place where the initial ISRO office, a small shed in which the whole research started. APJ Abdul Kalam and all has written elaborately about how they managed to set up the facilities there. Nothing was there. From nothing they have developed it into an international world class organization. In 1960s they had nothing, and now they have become one of the best in the world. Anyway, so this Tumba is from where right now it is a UN facility for upper atmospheric studies. Small sounding rockets, small rockets which are launched to the atmosphere, upper atmosphere, to study the atmosphere. Sounding rockets are launched from here. Sounding rockets are those rockets which are launched for upper atmospheric studies. Upper atmospheric studies. And even today we have rocket launch from here, but not for long distance, not to the outer space, to the upper atmospheric studies. And Tumba Center is known as equatorial. Why is it called equatorial? That is because, please listen carefully, our earth, we have equator, and Thiruvananthapuram is in the southern tip of Kerala or southern tip of India, and it is located say somewhere 7-8 degrees 8 degree latitude north of equator, not on equator, but so there is a concept of our geographical equator, north pole, south pole. So equator is the perpendicular bisector of the line joining the geographical north pole and geographical south pole. But there is a concept of magnetic north and magnetic south. Now, if you join that and if you draw a perpendicular to that magnetic north and south pole joining line and a perpendicular to that, say something like this. Okay. India, don't confuse. Now, you can see that this line, this equator, this is the magnetic equator. This magnetic equator is passing through Tumba. That is why it is called equatorial, Tumba Equatorial Rocket Launch Station, because the magnetic equator, it is passing through. Tumba is located on the magnetic equator of Earth. It has certain advantages. I am not getting into the details of magnetic equator. So, basically magnetic north pole and magnetic south pole, the line joining and a perpendicular to that is magnetic equator, and Tumba is located on the magnetic equator. That is why it is called equatorial rocket launch station. And on magnetic equator, there are certain advantages in physics because of the magnetic lines and the orientation and alignment of the magnetic lines. There are certain advantages in upper atmospheric studies. Please remember that much. There are certain advantages. Okay. There are certain advantages if you can, if you do research, because of the alignment of the magnetic lines, the inclination, declination and all. I mean, I do not know whether you remember all those things we studied in school. So, anyway, that is why it is a rocket launch station, Tumba Equatorial Rocket Launch Station. It is also under ISRO, but not for any major commercial launches of the satellites or the rockets. It is done only for equatorial, this is for mainly for upper atmospheric studies. It is for upper atmospheric studies, and that is what Tumba is all about. Also, we have other, Chandipur in Orissa. Chandipur in Orissa, it is mainly for defense research or DRDO, the missile testing and all. Okay. There is another, there is also a rocket launch station, but it is for defense purpose, missile launch station and not for the rocket launch station here. So, Chandipur on sea. So, that is another facility. So, please do not forget. So, but that is a not under the ISRO, it is under DRDO. Anyway, so we were talking about the main centers, we are talking about Satish Dhawan Space Center, that is the spaceport or where the rockets are being launched. Right now, we have two launch pads, launch pad number 1, launch pad number 2, and it is very important for our launching of the satellites. Then we have a liquid propulsion system center, LPSC, another facility under ISRO. It is also in Thiruvananthapuram. It is a major center because the liquid propulsion, this is where the fuel for the rockets, basically on the development of the engine and the propellant means the fuel. Okay, we are talking about the fuel. So, that is including the cryogenic engines, we will talk about this. Okay. So, and its test facility. It has a test facility at Mahendragiri. In Tamil Nadu, across the Kerala border. Okay. It is in near Kanyakumari. We have another Mahendragiri, the highest peak of the Eastern Ghats and all, we have said that is in Orissa. So, this is a different Mahendragiri for cryogenic engine test center. Okay. There is a facility, liquid propulsion system center, Thiruvananthapuram, including the cryogenic engine testing, and it has a facility for testing in Mahendragiri in Tamil Nadu, that is near Kanyakumari, just further south of Thiruvananthapuram. Okay. So, that is liquid propulsion system center number 4, and number 5 another big center is space application center SAC. That is in Ahmedabad. Okay. And there is something called ISTRAC, ISTRAC, that is ISRO Telemetry Tracking and Command Network. ISRO Telemetry Tracking and Command Network. This is where mission support, when the satellites are in orbit, especially the near earth orbit, when it is revolving around the earth. So, a series of network stations in Bangalore, Lucknow, Port Blair, even then of course, the Thiruvananthapuram, Mauritius, even in Mauritius. So, we have ISTRAC, that is ISRO Telemetry Tracking and Command Network, ISRO Telemetry Tracking and Command Network. So, basically to support the mission in orbit, and then a very important facility for us, that is called Master Control Facility, MSF, Master Control Facility. This is at Hassan in Karnataka. Okay, at Hassan in Karnataka, where these satellites. So, this is where the post launch operation. So, ISTRAC is mainly during the launch, but here the post launch operations, orbit maneuvering, changing, sending commands to the satellite in orbit. This is post launch operations. Or on orbit operations of a spacecraft. On orbit operations, I mean while it is in orbit, while it is revolving around the earth, if you want to give some commands to that, so that is done from master control facility. And we have a second master control facility because of the increased number of satellites. We have one more in Bhopal, the second MCF is in Bhopal, second master control facility in Bhopal also. So, we have 2. Then also there is a, if this is for the operations in our satellites in our orbit, but if it is for missions to moon, mission to Mars and all, this master control facility will not be able to do. We have a new facility called IDSN, Indian Deep Space Network. यार इसका पता करो ना, इसको क्यों नहीं मैसेज नहीं मिला, ये कौन सा हम अपलोड करते ही है. Indian Deep Space Network, IDSN, this is for controlling and tracking the mission beyond Earth, the mission to moon, mission to Mars or any other mission beyond our Earth. It is controlled from IDSN. Okay, it is controlled from IDSN, and it is located a place near Bangalore called Bealalu. Okay, it is located at a place called Bealalu. So, it is near Bangalore. So, with very large antennas and all, because it has to communicate to something beyond our Earth, and its attract gravitational force may be far away, millions of kilometers away. Okay. So, this is called this is mainly for interplanetary spacecraft missions. Indian Deep Space Network is for interplanetary spacecraft missions. Interplanetary spacecraft missions. Okay, that is called Indian Deep Space Network, which is located near Bangalore. Interplanetary spacecraft missions like mission to Mars, Chandrayaan, Mangalyaan, it is controlled, or rather commands are given. Any operation, any maneuvering, any radio signal to be sent, it will be sent from this place called IDSN or Indian Deep Space Network, or at a place called Bealalu in Bangalore. Sixth point is Hassan master control facility. For once a satellite is launched to the orbit, it is not that we have to, once it is launched, everything is over. We have to communicate with them, we have to get data from that, we have to ask certain functions to be done. So, how do? We do it from Earth by sending radio signals, and from where we give the radio signal? From the master control facility. Master control facility. So, these are some of the facilities. Now, what are we discussing? Now, बहुत लोग ये भी भूल गए. That is why Neha is asking, sir, repeat 6 point. भूल ही गया कि क्या बात कर रहे हैं. So, I said ISRO and its various organizations. Okay, that is the discussion which is going on. ISRO and the various organizations under it, and what are its function. I said headquarters is in Bangalore, then the first and the foremost center VSSC for rocket development, second is ISRO satellite center or UR Rao satellite center, design and development of the satellites, Satish Dhawan space center, Sriharikota for the launch is a spaceport, I said the spaceport of India. Then I also talked about Tumba also, because that is still a very important center for space research, but it is for research purpose now, upper atmospheric studies, but this is where our Indian Space Research Organization started. All our the scientists of yesteryears, whether it is Vikram Sarabhai, whether it is Satish Dhawan, whether it is U.R. Rao, APJ Abdul Kalam, all worked here. They started from here. All of them, that is the mother station. We started from here, then we are developed into a big one. Now, we also have a missile testing center from Chandipur in Orissa, that is a different story. Then we have liquid propulsion center in Thiruvananthapuram, very important because of the cryogenic engine, and also it has a test center at Mahendragiri in Tamil Nadu. Satellite application center, Ahmedabad. ISTRAC, another center, that is the ISRO telemetry tracking and command network. This is normally during the launch, how to support, and it has various locations like Bangalore, Lucknow, Port Blair, Thiruvananthapuram, Mauritius. Then of course, master control facility, post launch operations, maneuvering, on orbit operation, as well as maneuvering of the orbit. Any change in the orbit required, everything is done from master control facility. It has second center at Bhopal. Then also we have a center called IDSN, and there are many more smaller centers, but these are some of the major ones. So, the major facilities, this is what we are discussing right now. Now, let us talk about the various orbits. Various orbits in which we launch our satellites. See, please remember, from Earth, these satellites are launched to a particular height, and there it revolves around the Earth. Okay. So, a satellite can be in orbit, and it will revolve around the Earth, so that it will not fall down. Okay. And any object in circular motion, please do not forget, any object in circular motion, it requires centripetal force. Towards the center of the Earth. Okay, towards the center, there has to be a force. That is why it is revolving in, or it is in circle, or otherwise it would have left. So, if there is no centripetal force, what will happen? It will fly away. It would have been flying away. So, this centripetal force for any satellite which is revolving around the Earth is provided by the gravitational force of Earth. The centripetal force is provided by the gravitational force. The gravity of the Earth is providing the centripetal force for the satellites to revolve. Now, the question asked is, at what height from the surface of the Earth the satellites are revolving? So, there can be various heights. So, there can be a height like this, there can be even bigger height. So, there can be various orbits, that is what we are talking. At what height, when we say various orbits, at what height the satellites are revolving around the Earth. So, when we talk about this, we are only talking about at what height. Various orbits means okay. At what height these satellites are revolving around the Earth. So, one such orbit we call it as the low Earth orbit. Or LEO. Okay. So, normally there is no specific height, anywhere between 100 kilometers to 2000 normally. kilometers above the surface of the earth. Hundred kilometers to 2000 kilometers above the surface of the earth. We call it as the low earth orbit. So, our International Space Station, okay, it is between, is in a not exactly circular orbit, anywhere between 250 to 450 kilometers above. Or the remote sensing satellites. The satellites which take photographs, remote sensing satellites are photography purpose satellites, for photography. We will come to that. So, they are all in LEO, and nowadays we are also sending, now I said SpaceX for that broadband and all, short distance communication. Okay, this there can also be low earth orbit for communication. Okay, so low earth orbit, LEO, communication satellites. The best example is the SpaceX program for broadband. Okay, for the internet, okay. So, called Starlink, they are called Starlink. I will be teaching Starlink program by SpaceX, connecting or around 10,000 plus satellites in low earth orbit for having a global, okay, this is for a global connectivity of internet connection. Okay, it is for it is a satellite internet constellation. Okay, and they are saying in another couple of years, let me see how many satellites they are talking.